So here we have a giant TCR Advanced SL. It's a 2014 model, I believe. Not that the models, I mean, basically with the models, with the years, most of the time they'll get at least 2, maybe even 3 years out of a model, and they'll just change the paint, every year just to look a bit different. But because of the cost of the tooling, they want to get as many bikes out of the tooling as they can. So it's typically sort of about 3 years. So, so this model was around for quite a number of years, and yeah, as I said, this one I believe is a 2014. So it's got the blue highlights. I think this one came with the Durace Di2, if I recall correctly. Now, it came in because this crack that you can see here on the that's on the seat tube. So now what happened was that the owner was in an accident. He had a crash. He had a crash on the bike, and he took it into one of the bigger shops here in Melbourne, and they did their crash assessment on it, and they couldn't find anything wrong with it, and so they said, yeah, the bike is okay, good to go, and so like he wasn't hurt. So the next day he ended up he went for a ride on the bike, and within no time at all of riding the bike, that crack developed. So obviously, less than ideal. There was some damage to the bike as part of the accident, which then, when he used the bike, it revealed its full extent. So, it's one of those things where visually you often can't tell, what's damaged. That's why it's important to do the scans. So, if there was an underlying delamination, like if your leg knocks the tube, for instance, and you get a blunt impact, you can get a delamination without there being any sort of real obvious indication on the surface. So, so this is an example of that. So let's have a look at it. I've turned the camera off. You don't need to see me. You're more interested in the bikes. So let's have a close look. Now, before people say, oh, this is just one off, like I've scanned hundreds of giant TCRs over the years, and this one was picked out because it was a little bit different to how they normally are. So, there was a couple of indications on this one, which when I scanned it, so apart from the crash damage, which anyway, I'll show you those as we go through the bike. But that's the overview of the inside. Let's do what we normally do. Let's go straight to the bottom bracket. So as you can see, it's not too bad. It's actually pretty good. There's a few areas of resin pooling sort of along here, and that resin rich sort of from the bag. The bonded joint between the chainstay and the bottom bracket through here and here. Well, that's it needs to be a straight line. Oh, gee, must be something on the mouse there. I tried to do a straight line. One of these days I'll get a pen or something. That bonded joint's really good. You can see there's plenty of adhesive sort of spew out, so plenty good bond area there. So no issues with that. The bottom bracket. Now these are a press fit, and they're probably one of the few press fit systems that are actually very reliable. We don't hear any sort of issues with with the press fit on these. The that's molded in, so the fitting there is molded in, and it's for the Shimano system. So again, no issues with that. You can see there are some extra swatches of material there, and there, which will be placed in as sort of stiffeners over that large flat area, and probably also to tie in and retain the bottom bracket plies and locate those. The little hole here for the Di2 cable coming out the back. So moving down the chainstay, overall it looks pretty good. Like, it looks fairly clean. I mean, we've seen some which are pretty bad over the time. This one looks pretty good. There is some excess resin sort of through here and here, so where there's like a crease in the bag, so a little bit of resin pooling on the surface. And there's also, if you can make out, just a little planar void there. So a couple of little things, but overall, not too bad. So to the dropout, and it's a carbon dropout which is bonded in. You can see there's plenty of adhesive sort of through here and up on the seat stay as well. So there's no issues with the bonding there. A couple of little voids in the compression molding, sort of here and here, but that's totally insignificant. They've used a bit of foam to sort of fill the cavity here, that white material, and there's a void there, but that's not a big deal. We do see some wear on the outer face on the dropouts with these, particularly where being used on a trainer, an indoor trainer, where you're taking the wheel on and off. Sometimes the outer face gets a bit worn out, so that's something to be mindful of. But the inner face, being the metal, is no problem at all. The dropout design is good. Where the holes are, there's plenty of meat or carbon around those areas to not like somewhere where they drill a hole to mount the derailleur. It leads to failure of the tip. So overall, a pretty reliable design with a couple of little issues if you're using it on the trainer. Moving up the seat stay. Seat stay looks really well made. There's no issues with that. It's all clean. You can see how thin the laminate is, and it's one of the reasons why seat stays often do get damaged in crashes, because they are so thin and so light that they just get damaged very easily, and they're so sort of exposed to damage. So that's but this is a good example of what a seat stay should look like. You can see also where the dropout is bonded in, sort of through here. There's a bit of extra fabric reinforcement to reinforce that area, and it's the same on the chainstay as well, actually, where the dropout gets bonded in. So yeah, that's all good. And the junction to the seat stay to the seat tube, again, there's a bonded joint. You can see the adhesive excess through there, so plenty of adhesive. That all looks pretty solid. There is a small void you can see here, but that's sort of right in the middle of it. The consequences of that are going to be very, very minor. If it was open to an edge, you're more likely to get some peel stress, but where that is, that would be acceptable. The other thing you can see is a void up on the seat tube, so up through here, up the top, and you'll see that it's coincident with this this crease in the bag through here and that excess resin. So there's obviously been a little bit less than ideal compaction through there, and you have a build-up of thickness of material, so more likely to get a void. So here's a view of that junction with the top tube, the seat tube, and the seat stays. You can see the void that I was talking about in the previous slide there, and these wrinkles of or creases in the bag, which have led to some variations in the compaction. So another one down here. So it's primarily resin on the surface, but because that where that wrinkle is, it can't provide a uniform compaction on that area. So if you're going to get a problem, that's where you'll get the problem. So it's not so much the buildup of resin which is the issue, it's the variations in compaction, and which can lead to the planar voids and other issues like that. So that's the concern, and it's not always the case that where you see these buildups of resin, it doesn't automatically mean that you're going to get poor compaction, but it's more probable that you will in those areas. And we've got a real close-up look here of how they join the front triangle and the seat tube. And so you've got this adhesive fillet here, so that's bonded, and then you've got the top tube which comes there, and then that's bonded there, and then you've got extra plies which are laid up over the top to join those two tubes and have a nice strong joint. And if you look very closely, I've drawn the line over it, but if you look very closely, there is a little bit of porosity right along that edge at that interface with the existing material and the overwrapped material. There was a little void in that adhesive. That's no issue at all. That adhesive is more there to bond the tube in place prior to being laminated with the extra material over the top, and then once that carbon fabric is placed over there, then that's really the primary structural connection. And this is the lower joint of that top tube to seat tube. So again, same sort of thing. You've got the adhesive fillet, and you've got the tube coming to there. And again, you've got a bit of a void. You can see it a little bit better. It's more pronounced on this one. So a bit of porosity sort of along that interface through there, blending into that underside of the seat tube junction and top tube junction. Then we've got the seat mast. So it's quite a long seat mast on this one. So he must have been a tall rider. So the again, we touched on those wrinkles, so I won't talk much about that. But what we do find with these is we often see damage at the seat clamp area, sort of through here. So on the head for the seat clamp, the saddle clamp, it's got a little pinch bolt. Now, if the fit isn't right, people have a tendency to over tighten that pinch bolt, which then creates a point load and delaminates the ISP. So it's really important that the fit between the clamp and the ISP is nice and snug. So the aim of that pinch bolt is to stop the thing coming off, and when you lift the bike. So it needs to rest on the top edge up here, and it's important that is cut square and accurately, and then they provide shims to micro adjust that height. So, but it's important that that's a nice square cut, and that the weight is taken up by the base of the clamp resting against this surface here. So it's not the pinch bolt which should be doing the work, and so it's really important that you get that fit right. And if you find that your clamp head is rocking or moving on the ISP, what you can do is you can shim it up to make it to make the fit right. And there's a number of different ways you can do that. You can use some additional material, like a common one is like a Coke can or something like that. Drink can. Yeah, you can even use some like thin plastic film, or what we do if we're repairing that area, we can match the thickness with the paint. So we'll build up the paint thickness to get it a nice and snug fit. So then it'll you don't get any of that rocking, and you can just nip up that pinch bolt, and that retains it perfectly. And then down the seat tube area. So this is where the bike failed. So where the cracks are, you can see on the inside, sort of through here, like it's cracked. But there's delamination sort of either side of that. Now there are some of these areas that we spoke about before, sort of through here, and so there may have been some areas of porosity or voids which contributed to that to that crack propagating. It's one of those things very hard to tell after the event. You really need to find and identify these flaws before the part fails. But yeah, I mean, as I said, that's sort of hard to say. And further down where the front derailleur hanger mounts, again, you've got a little bit of change in contour, and then you've just got the bag bunching up sort of in this area here and leading to those resin wrinkles. And then also as it flares out sort of down here, the bag has to have folds in it to allow for that, and that's what you're seeing there. Now there is a fabric reinforcement where they drill the holes. You can't really see it that well on this shot, but it basically comes sort of like there and up to about here. So yeah, a bit of extra fabric reinforcement to reduce the chance of delamination during the drilling process and fitting of those fasteners. And then we go to the down tube. Now this is where we start seeing some issues, and you can see this area here. Now that's an indication of the compaction being sort of less than ideal, and then you're starting to see these sorts of things, these little almost look like bubbles, which effectively they are. But yeah, we'll have a closer look at that stuff in a minute. The bond between the down tube and that bottom bracket, like there's a bonded joint through here, and that's all pretty good. Very small voids in porosity in the adhesive, but then that's overwrapped, and so there's no issues with that per se. Again, extra bit of resin stuff here. Yeah, but this area is still not yet. It's still okay. It's still okay. It's so then moving up, we can see a few more of these voids. So here you've got one there. You can see something there, and here. And also, again, you've got from those creases and stuff, you see them there. So all that's sort of starting to become a little bit of a problem. And when I scanned the bike, basically, there's another one there. All along that edge, that corner through there, things were popping up on the scan as voids. And so here we get another look. You can see a nice view of that void there, and the other ones here. And but what was of real concern when I scanned the bike, there was an area in this region here, and that all showed up as being areas of porosity, and I'll show you a bit more of that on the close-up a bit later on. But that's quite a concern, and it's right near the transition between the EPS type molding system and then where it just goes to a regular bag. So you've got the bag on this side of the line, and you can see the line there, and that's sort of where the issue is greatest. So that's a bit of a concern. So here's the head tube area on the bike. A couple of little things to note. You can see there's a cable guide sort of molded in there. The other thing that's interesting is there's like a reinforcement rib through here. So it's built up. There's a bit of extra thickness, bit of extra material to provide some hoop strength through that area, because it's a large open area and it needs just a little bit of stiffness to stop any buckling through that zone. So that's quite well done. The rest of the molding looks pretty uniform. It's really that transition through here, as I spoke about before, where the problem was. Looking at the lower bearing seat, no issues with that. That's all molded in co-cured as part of the head tube. I've never come across any issues with that. That's always been a reliable area of the bike, as in my experience anyway. So the only other thing, and you can just barely make it out, there's a little bit of porosity sort of right on this little laminate through here. So a little porosity, a little planar void. Not the clearest shot to show it, but yeah, a little bit there. And then the upper bearing seat, pretty much the same, all co-molded. Little tiny void, sort of right here. I'm not worried about that. They do have this sort of shape molded into it, sort of through here and through here, to sort of prevent buckling and sort of provide a bit more stiffness. So that's sort of a structural feature there. And you can see the edge of the EPS and the bag sort of transition along that edge, and you're getting that characteristic sort of resin line of that joint. Then moving along the top tube, again we're seeing some voids sort of through here and here, and we'll get a bit of a closer look at that stuff in a minute. But yeah, I mean, overall, you've just got a few little issues with this, and you've got the cable guides molded in, and there's extra sort of fabric reinforcement through here, which is fine, and you also see a bit of extra fabric at the junction where they join to the seat tube. But yeah, there's a bit of a concern, and I'll show you in closer look at some of these voids in a minute. So this is on the other side, so the other half of this frame, and there's a couple of things of note here. And I mean, first of all, you can see it. I've cut through it through there, and that was because of that void there. I wanted to show you what that void looks like through the thickness. So I'll show that in an upcoming slide. But you can see there's a whole range of little issues. So there, obviously there. You can also see a little bit through here that it's not compacted very well. Also sort of here and here, and lines here and here. So a whole bunch of little issues with this. So let's have a closer look at at that void. So you can clearly see the void. It's pretty obvious, but what's probably a little bit less obvious is the porosity, and you can see that it continues all the way across, all the way over to here. So that's really going to compromise the mechanical properties of the tube. So the outer face, the side face, in this case it's the non-drive side, any impact sort of coming sort of from this direction here, which is, even bumping the bike up against a wall or something like that, but any sort of little minor incident like that, because the tube is compromised, then that damage is just going to propagate and lead to bigger problems. Again, on the other half of the frame, there was the same sort of problems in that down tube, head tube junction area as what we saw previously. So on both sides in this area here, there was issues. So what I did, I cut through the section, and yeah, we can have a closer look at that. So here's the cross section, and you can clearly see the voids and the porosity, more voids and porosity. You can also see some of the Rouse yellow pencil on the outside of the surface, a bit of residue there from when it was scanned. And that's how it was identified, that these problem areas, which led to the bike being scrapped. So, basically the bike came in because it was damaged had that damage at the seat tube, but when we went through and scanned the whole bike and we found all these other areas, we decided let's scrap the bike, because we don't know how these issues are going to present themselves over time. So these we know that voids and porosity reduce the mechanical properties of the part, and they shouldn't be there. Then you don't design them in, and when you have these type of flaws in an area such as the down tube and head tube junction, which, let's face it, we don't want that area to fail, then you can have problems down the track. So this bike was retired from that, and yeah, it's basically, because it was less than ideal. So as you can see, this particular frame had some issues with it. It was certainly less than ideal. So, all those flaws which were identified, which they may or may not lead to failures down the track. That sort of stuff's very, very hard to actually quantify. Did the initial failure at the seat tube, from the accident, were there production flaws that propagated that? Again, that's really hard to identify, because the damage will mask any of that sort of stuff typically. So it's you really need to do a deep forensic analysis into that. What I will say though is that and I can't speak for other locations, like US or Europe, UK, etc. But in Australia, the Giant warranty is second to none. So if you identify manufacturing faults in their products, they'll sort you out, and they won't go and hide behind the bush and threaten legal action and all this sort of stuff against you. They'll just go, look, there's a problem, we'll fix it. And that's been my experience. I've when I find stuff and I for customers, and I say I'll take it back to Giant, and it gets sorted out. So if your experience is different, put it in the comments below. But we can only go on. I can only comment on what I know about. So
Yeah, and that's been my experience. Anyway, I hope you learned something on this bike. I do get asked, on all sorts of stuff all the time on different bikes. I've got a lot of bikes in the queue to get cut up, and I might do a poll. So anyway, there's a whole bunch there. I'll do a poll on the community channel, and yeah, you can have a vote on that. So in the meantime, stay safe, enjoy your riding. Hope you can stay away from this COVID pandemic, and yeah, keep well. All right, see you next time. Bye.